Okay, it is time to tackle part 2 of 6-7, inverse relations and functions. Part 1, we talked very briefly about how to do a table, how to do an equation, and how to do a graph. Today we're going to do a little more complicated equations. Something worth mentioning that I didn't yesterday is if the original is called f of x, then the inverse is called, here's how you note it. You use an f with a -1 as an exponent, like that. And that's called the inverse of x. Okay, so just so you know, inverse is noted with a -1 as an exponent. Before we proceed on, the book does some really bad assuming that you know a whole bunch about stuff you probably forgot about. So we're going to go to the last page. There's something we have to remember for today. And that is all about domain and ranges given different types of equations. So let's say we have an equation with just a plain old x in it. The name is linear. Yeah, you should remember that, but just in case, let's remember that it's linear. The shape is just a straight line on a graph. So we can write straight line. And straight lines, are straight lines a function? Absolutely yes. If you have a y equals mx plus b equation, they are going to be functions. How do you find the domain values? Well, a straight line goes left and right forever. So the domain values, x equals all real numbers. How do you find the range? Well, since it also goes up and down forever, the y values are also all real numbers. The inverse of a straight line, inverse of a linear equation, is still a straight line. So it's actually still linear. The inverse is still a linear equation. And what shape is that on a graph? Again, it's just another straight line on a graph. Is the inverse a function? Absolutely. A straight line, or I should be very careful when I say a straight line. It's everything but a vertical line. As long as it's a tilted line or horizontal line, yeah, it's definitely going to be a function. What is the inverse? Okay, here's what's kind of cool about inverses. They just steal these guys' properties. So domain is still x equal and range is still y equal. And the domain gets this range, so all real numbers, and the range gets this domain, all real numbers. So that's linear. Now it's time to talk about x squared equations. Maybe what I should do is go to my calculator quickly and show you, hopefully you know, x squared equations are what we call quadratic. And they make a U shape on a graph, a parabola. Either a parabola going up or a parabola going down. So we can write the word parabola. Okay? Are parabolas functions? Well, take a look at that graph. Does it pass a vertical line test? Yes, it does. The domain, just like you learned in chapter 4, it goes left and right forever. So it's x is all real numbers. It's hard sometimes to remember all of this at once, but it is unfortunately something we have to recall. The range, well, sometimes the range, like it's either y is greater than or equal to a number, depending on what that bottom point is, or if it opens down, it's y is less than or equal to a number. Okay? So it's not all real numbers because it doesn't go up and down forever. So what is the inverse of an x squared equation? Well, I'm going to show you on here. I'm going to prove to you that the inverse is a positive square root of x and a negative square root of x equation. So the inverse is a positive and a negative square root of x problem. The shape on a graph is a horizontal parabola. So it's still a parabola, but this time it's horizontal. Because it's horizontal, see if I draw a vertical line, it is not a function because a vertical line would touch twice. Now remember what I said about the inverse domain and ranges. It's still x and y, it always is. Domain is always x, range is always y. But the domain gets this property. So it's either x is greater than or equal to a number, or x is less than or equal to a number. So see how I got this property. And the y's are going to be all real numbers. Okay? Because it goes up and the inverse goes up and down forever. Okay, square root of x. This is a square root function. And square root functions always have a starting point, and then they go somewhere. So they pretty much look like half of a parabola on a graph. They might open up, they might open down, they might open left, they might open right, but as long as you know they have a starting point and they look like half of a parabola on a graph. Is this a function? Yep. If I were to draw a vertical line through here, it would only touch once. I have to redo the domain for the square root because I said it wrong in the first time. So the domain of a square root, what you do is you take the inside stuff, like what's in the square root, so the inside stuff, whatever's inside your square root, and you set that stuff greater than or equal to 0. And we are going to, and then you have to solve for x. We're going to do this in the notes, so if that doesn't make sense, we'll definitely do it in the notes, I promise. The range is a little harder. You have to take whatever value you got for x. It's going to be either y is greater than or equal to, it might be less than or equal to if it opens down, but usually it's greater than or equal to the number you get when you plug in x. So I'm just going to write a number, but it's the number you get when you plug in x. So it is very limited. Now its inverse is, and so if I were to type in my calculator just the square root of x, so you can see what it looks like on a graph. There's the starting point, goes up forever. The inverse is, this is weird, it's just half of a parabola. So it was like if you could fold it up, it's just going to be right here. So it's going to be, or excuse me, I think this one would be right here. Be half of a parabola if you folded it. So the inverse is x squared, but we need to note that it's only half of a parabola. Okay? And so it is an x squared, it is quadratic, but it's only half of it. The shape would look like, it's kind of like you tilted it 90 degrees. It's like if you could take this one and fold it, see how it's just half of a parabola. The inverse this time, if you were to draw vertical lines, yep, the inverse is a function. Now remember, the domain is always x, the range is always y, and they just steal these guys' stuff over here. So it's greater than or equal to whatever y was. I'm going to write that. Whatever y was. And y is going to be greater than or equal to whatever x was. I think what I'm going to do is save these bottom two for tomorrow for 6-8, so we can talk a little more about those tomorrow. I know it took a long time, but you needed all of that in order to accomplish the questions for today. So going back to the very front page. Let's say that we have an equation that's a square root equation. What I'm going to do is I'm going to type it in my calculator so you can see a graph of it. Okay? As you can see, it starts at +2 and it moves to the right. You should know that this moves it right too, by the way. Maybe we even want to write that. A -2, you remember, hopefully it moves it right 2 units. We learned that in Chapter 2, Section 6. So the general shape of a square root is a starting point and it goes over, just like we talked about on the last page of the notes today. Because it's a square root, the domain is very picky. The domain is you take the stuff inside, x minus 2, and it has to be greater than or equal to 0. Because we can never let the inside stuff be smaller than 0. Add 2 to both sides, and we get the domain is x is greater than or equal to 0 plus 2 is 2. Now it's time for the range. Because this is a positive equation, y is going to be greater than or equal to whatever we get when we plug in 2. So we're going to do the square root of 2 minus 2. So that means y is greater than or equal to the square root of 0. So that means the range is greater than or equal to, 0. Okay? What is the inverse of the original? See that f-1? That means inverse. Find the equation. So we are going to rewrite the original. Everybody write original and do y equals square root of x minus 2. Now let's do the inverse. Yesterday I did this with a blue marker for you, so I'll do it in a blue marker today. Inverse. X equals square root of y minus 2. Do you see how I switched the x and the y? Now I need to solve for y. So I have to, just like I learned in 6-5, square both sides. So I get x squared equals y minus 2. The square root pops off because of the square on both sides. Ooh. X squared. Add 2 to both sides. And your new equation is x squared plus 2 equals y. This is the inverse equation. Notice it's actually a parabola, isn't it? But remember, it's only going to be half a parabola. What is the domain and the range of the inverse? Remember, that stands for inverse. So I'm going to write domain. And remember, it's going to be x. I'm going to write range. Remember, it's going to be y. And just switch these two qualities. So x is going to be greater than or equal to 0. I'm going to do that one more time so you saw what I did. X is going to be greater than or equal to 0. And y is going to be greater than or equal to 2. And that's how you find the domain and range. As long as you found the originals, now you have the new ones. And it says, is it a function? Well, remember, way back here, we started with a square root function. The inverse is half of excuse me. The inverse is half of a parabola. So yes, the inverse is a function. So remember how I talked about it would be like half a parabola? Yes, this is a function. Let's try that again. This time the original is going to be x squared. X squared is a quadratic, so this is something we need to remember is what would this look like on a graph? It would be a parabola. I'm going to put it in my calculator so you can see it. There's the graph of it. It's down 5 because of the minus 5 in the back. Now, what is the domain of all parabolas? Well, if you forget, go to your handy-dandy chart we made. The domain of all parabolas is x equals all real numbers. So the domain, x equals all real numbers because it's a parabola. Now we have to be careful of the range. If, again, you flip back, the range is greater than or equal to, this one opens up, so it's greater than or equal to a number. And if you remember, it's the vertex number. So in this one, hopefully you can remember that this vertex would be at 0, -5 because of the equation. So this time the range would be greater than or equal to -5. And that is because it starts at -5 and it goes up forever. So what is the inverse? What is the equation of the inverse? Well, let's write original is y equals x squared minus 5. I'll take my blue marker to help you find the inverse. X equals y squared minus 5. Now we have to solve for y. Add 5 to both sides. So we get x plus 5 equals y squared. And in order to solve for y, take the square root. So the inverse is a positive and a negative square root x plus 5 equals our y. And that is the equation of the inverse. Remember, if you have to physically draw the square root sign, you have to use plus and minus. If I graph this on a calculator so I can prove to you that that is the inverse, I have to do the positive square root of x plus 5, and I have to do the negative square root of x plus 5. Now when I hit graph, it's going to do the positive side first, and now it's going to do the negative side. And if I could like fold these together, they would fold one right on top of the other. What is the domain and the range of the inverse? So all we had to do is switch these two up here. So let's write domain, x values, and let's write range. Those are the y values, and just switch their properties. So the domain is going to be greater than or equal to -5, and the range this time is going to be all real numbers. And you can see that reflected in the calculator because, look, it starts at -5 on your x-axis, and it goes on forever, and it goes up and down forever, which is why your range is all real numbers. Now, is this a function? Remember, it started as a parabola, so the inverse is going to be a sideways parabola. That does not pass the vertical line test. This is a big fat no. It is not a function. Let's try it again. I'm going to start a new video, though.